Oh, I didn't change the title before I started. Always the problem. All right, well, I've got a crazy day today. That's going to bounce me back and forth between a bunch of things, but I wanted to get started with this before I go any, just to at least have a project to do to stream, because this one seems to make pretty good sense. Just do something like this. There we go. All right, let me get a title for the stream. We are fixing a bug in GWT today where a ternary causes a compile error. We get a assertion failure where the it says, well, this output here is not what I'm expecting. And the basic problem is that when you write an expression like this, where you've got a string concatenated to something else, the compiler has to figure out what the type of this expression here is. And when you do a ternary operator like this, where you've got a one type on one side and one type on the other side, the compiler, the GDT, the Java compiler, will look at these and try to figure out what the common supertype is to express what this needs to be in order to concatenate it to this. You may not be aware of this, but the way that concatenation works in at least plain Java is that there's a string builder, and so it needs to decide, is this a string that it should just concatenate it? Is it a number of some kind, so it should figure out how to append it? Is it an object, so it should call toString on it? And, or is it if it could be a primitive, and it ends up getting boxed with comparable and object and everything else, it has to call toString. There is no other way to handle that, which means for a primitive like this, it has to box it first. And GWT has this assertion here that you can't have intersection types when we look up a type like this. So if we look just at this part of the error, and then ask for stack trace, I don't have IntelliJ set up completely properly, so it's complaining about all my JUnit stuff here. Anyway, so this is the part of the build that's actually failing. It's looking at a conditional expression, which means it's a ternary. We've got the condition, the value of true, and the value of false. For those who haven't gone through this kind of thing before, we read them in backward order because each of those tokens was pushed onto the stack when they were encountered, and that means that the third part, so you push true, you push the then expression, then you push the else expression. And so we have to read them in reverse order. We read the else expression, we read the then expression, and then we read the condition. And then we finish reading those things and build a ternary that we're going to put on the stack for the next piece here that's handling things. The GWT AST builder is part of the precompiler. So if we look at the call of the stack trace here, what we're doing right now, we are currently precompiling. We are actually taking the Eclipse GDT compiled output and transforming that into GWT's own AST. And in the course of translating the one to the other, we're hitting this problem. So we've got an AST type here, a JDT type here. We can see org Eclipse JDT internal, compiler AST for the package there. And Slack is noisy. Just an hour. I've only probably got about an hour here. And then we're going to reconstruct that. And part of what pop here does under the covers is it says, okay, you've got some expression from the JDT. We're going to read that expression and make it into a GWT AST expression. So, but when it figures out the type of what the entire condition is, it does this typemap.get, and typemap.get is in this reference mapper type, and one of the first things it does is say, okay, well, what's the signature of this binding? What's the signature of that type we should have here? And the first thing that does is say, this had better not be an intersection type. It can't be a Java 1.8 intersection type, and it can't be an intersection type from earlier versions of Java either. And I just made a change here because this used to just blow up and say assertion error null. And now we have, I get you to show the diff here? There we go. And now we have the binding debug name so that we can say, okay, so here's what it was trying to do, and that failed. And this is now what we see here. It says assertion error, and it says, here's the kind of type I was trying to find. This isn't quite enough for us to really solve the problem yet. We need to figure out what these types here are and find some better way to handle that. So that's probably going to be our next step here. Okay, and then the other change we made to get it so that we actually see here, compiler test at line 587 is true, question mark C, colon, C. That was over in, let's view the whole commit. Just click it like this. JUnit shell was, it turned out, was invoking the compiler in a particular way, where it wrapped it up in a try-catch. And unlike the other ways that we usually run the compiler, we were not, we were just throwing the log message and saying, hey, there's a stack trace, whatever. And we've actually got this utility here that will log and translate exception, and it will work its way through the exception and say, okay, if you are a, put this back up top again, if your exception here is an internal compiler error, then compiler errors come with a node trace, and we can use that node trace to work backward and say, hey, user, this is the code you wrote that probably is causing this problem here. I'm going to open this up over here, just so I've got my usual streaming setup. I'm, like I said, low on time, so I just started streaming without really thinking too hard about it. There we go. Okay. So, in short, this is a very simple test that causes this, and it causes it by needing to reference this as some other type. I believe we could just as simply say something like object result equals this, and then try and rerun the test. And the test takes, looks like 12 seconds to run the whole thing. So we'll let that run real quick. We then could say, okay, well, result needs to be a string once we're done, because we'll concatenate it with this, but right now it'll be an object of some kind. And even figuring out what the type of this expression can be, or will be, is going to fail to compile. And the reason we need to know this is that the compiler later on wants to do operations like tighten up object to reference only whatever type this happens to be here, which might in turn allow us to optimize away instance of checks and all kinds of other fun things. So it's important. Oh no, that did not fail to compile. Well, that is interesting. I wonder if we need some other kind of dispatch to make it happen. So what I'm suggesting is if we had a public private void go that takes a string and a private void go that takes an object. And then instead of assigning to result, we say go with that. Now the compiler, in the course of figuring out which one of these we're calling, needs to compute the type of this in order for the type inference to here to work properly. So type inference has changed as Java has grown. This is the old kind of type inference that it used to be capable of. The newer kinds of type inference is much more powerful with the var keyword. Sorry, the var is not actually a keyword because var can be used as a variable name. There is I forget the exact word for it, but it's not quite a keyword. A type? It's not a type. Anyway, using var, you can say, hey, compiler, figure out what this type, this whole expression here is going to be. Nope, that is still happy. So that picked some dispatch here. So it's really only in cases like this. I really wonder... Well, we're not going to worry too much about why. It's important not that it fails, or exactly what makes it fail. It's just important that this case is one of the cases that can make it fail. So let's get that error back in again, and then I want to modify how we run the tests so that I can hook a debugger to it. Specifically, what I'm interested in is the types of these other expressions along the way. We won't be able to do this properly. We'll be able to move into here and say, Okay, well, if I peek ahead of time here and find out what all these are, we can find out what the types are of those pieces. So I'm going to reorder this a little bit. And there we go, it failed. And then let's see how to get a breakpoint in here. So we are in, this isn't the compiler itself, but the test actually lives in user, GWT user. So we have to run the user tests to do this. And we've got some extra JVM args we can add here. So just like we normally do to debug a remote JVM, we can grab our JVM args here and say, oops, still not right. Need a space there. Enable assertions and stop the debugger here. And actually, we're going to have it suspend as soon as it starts, just because the test is fast enough we might fail right away. So we'll wait until we get the log line here that says, hey, it's stuck here. One of the important takeaways here is that GWT is just a Java program. There's nothing magic about this. It may be complicated, but you can use traditional profiling tools and debugging tools to figure out what's going on. All right. Did I actually set a breakpoint? Oh, good. I've got other breakpoints set. This one is for what exception? Null pointer exception. So let's turn off null pointers. We don't need to get those. We do want to pause on assertion errors. That'll be right. That's what we want to stop on. So that'll actually catch us here. Okay, so this is a class cast exception. Unfortunately, this is one of those class cast exceptions that the JVM itself relies on to do its work. And there's a whole bunch of them here, and that is awesome. Not awesome. That is something we have to live with. So we got to get past these. Class cast exception is not our problem here. That's not what we're bugging today. Okay, so here is the breakpoint. We have the binding instance, which is the type. It is an intersection type binding, Java 18. Sorry, Java 8. And there are 3 intersecting types we have to worry about here. And one is object itself. Interesting that serializable extends object, but comparable extends null type, and object extends null type. It's confusing to me. But it doesn't matter. We're not here to take apart... Oh, it's because it's a parameterized type. So they're different. We're not here to take apart JDT. We're here to take apart GWT and understand why it is doing what it's doing here. So if we examine really quickly each of these expressions, we've got character value of, so it automatically boxed C already. So that's probably part of why the other tests didn't have a problem. I don't know. We'll have to find out. It's already boxing this up to character, capital C character. And the true is just going to be a string, literal. Okay. And then the condition is, of course, a Boolean expression. I'm sorry, it's actually a Boolean reference. And the reference will itself be a static Boolean, which has the initialized value of true. Okay. So let's look instead at what we have here. There's a char literal C, which apparently was rewritten to character.value of. Interesting. So I guess pop already did that. Maybe box or unbox. So this was responsible to say what exactly? We pass in the char literal C itself. Pop is going to say, okay, here's the resulting J expression and the original GDT expression. Maybe box or unbox. X has implicit conversion. Let's see what that was here. It was X value of true. Implicit conversion is 546. That's an int, I guess. I'm not really sure how to read that. We'll find out in the next overload how to read that. Do not unbox. Do not autobox, sorry. It's false. We are allowing it to autobox. Do not is false, so it is true. Autobox. Conversion, GDT requires boxing. if we look at this for, what's the number? 546. The answer is true. What is this method going to do here? It's going to say implicit conversion and boxing is not 0. Okay, so there's just some bit that's set specifically here for each of these possible kinds of conversions that may happen. Then we return box of get the primitive of the current class's scope and the implicit conversion. Oh boy. Okay, suffice it to say, we end up with the character value of. So this is the boxed version of the primitive. And then this type map lookup is based on the original GWT type. We step into that to say, okay, well, what do I do with this? We get this binding here. We try to do this. So either way, we're going to have the ability to call one of these if we didn't have the assertion. If we skip the assertion, the code works. That's worth pointing out. The assertion may be overzealous, or it might be possible that there's a better way that we can determine what this type needs to be. So if we look at binding source name, it's going to be object and comparable and serializable as a char array, which we turn into a string. I guess for this one, we'll make it more readable. Otherwise, we've got constant pool name, and this is going to depend on if it is a base type. So Alt F8, is it a base type? False. So we would have taken this branch anyway. Constant pool name, Alt F8, is Java Lang comparable, which is probably something like just take the first one, or maybe the most specific one. We are in a intersection type binding 18. Let's jump to type source. And then we want to look at the source name and the constant pool name. Source name is just chain them together with and, grabbing each of the intersecting types, and then given a string. Why are we building it that way? This seems a little heavy-handed, but okay. And then we want the constant pool. Oops, wrong button. Alt, Command 8. Constant pool name is, if erasure is not this, then we erase it. If the intersecting type ID is object, then we do the first one. So we skip object and jump to the second. And we just grab one of the interfaces that's present there. So what that means is we're going to lose the other interface, which is important because if there was multiple overloads that we could be calling, hypothetically, I understand that we're actually going to be concatenating a string here, but hypothetically, we could grab the wrong interface, or not enough information if we do it that way. The way I'm inclined to think about fixing this, and we'll have to do some more tests and make sure we don't break anything else, is say, if we can ask the J expressions, hey, you've got this one and this, can we find the greatest common type here? The nearest common type, rather than relying on GWT to tell us. So is this something we can easily say? I'm probably in the wrong frame here to try and debug that. Let's see. Here we are. Is there some way to say, hey, what is the type going to be of this if we... No. Okay, so let's ask the program instead. Usually there's a J program we've got access to. The program that we're building presently. We got the current class and current method, but these are the GWT types. Here's the node stack that we are building, which will have the program probably at the top. No, it's just the expression itself. All the expressions we're working our way through. This may be too early to even have a program yet, because we haven't even figured out all the types that are present, so we really are relying on the JDT to tell us what to do. We've got a couple of these types available already, because we're going to go ahead and pre-cache those, because they'll be needed. If we go up the frame here, do we have anything that gives us a program? Let's look actually for where JProgram is instantiated. So JProgram is the the program that we're going to use here. Actually, that might be relevant here. Oh, hey, we're in this frame already. We're in. No, I jumped ahead. We're probably in add type, or nearly so, or we will call add type shortly. Unify AST is going to call add type. Okay, yeah, we're probably too early. Let's find the constructor. This comes from here. Let's look at who calls this, who calls this. I'm doing something wrong then if that's the only constructor call. We've only got one call here. Let's just use navigate call hierarchy. This takes a little while to build. Okay, that wasn't actually so bad. Precompile. So how far off are we here from the actual call stack we're in here? Because this is sort of like a call stack to say precompile, or sorry, compile will call precompile, we'll call precompile, we'll call precompile, we'll call precompile, we'll instantiate a J program. If we look at this line here, 192 in the compile method, 192, okay, so we're actually in the same spot. We'll go up a few frames to 210 in precompile. 1, 2, 3, 243. So we should already have a program. 210 is up here. Compilation state should have a J program then, I guess. Unless it's out of scope already. Oh, we nulled it out. This is pretty early in the compiler, and I am not as well versed in this. I am used to working on the compiler optimizations. It's probably this direction. Let's see here. The compilation state, which had it, gets built into the pre-compilation context. Might have it here. Come on, go gadget, expand and show me things. Why is it not doing that? Oh, I had it backward. Line 210 is where we're building right now. But we won't actually get the J program until down here, 243. This is where the J program will finally be created. So we don't have a program we can query yet to ask what this type should be. So we either need a different way to express this, or we need a different way to construct a GWT AST J type. Tell it, hey, this is a union type. Let's see here. I'm a little scared about making a change like this if we don't exhaustively get it right. So let's see. Instead of that, do we have some other way to take this resolve type and decompose it and then recompose it into a J type? The J type is the abstract class that describes GWT types. We have a declared, it won't be a declared type. So it looks like GWT might drop union types. Unless there's a type reference instead. J runtime type reference. A node whose evaluation results in a runtime type reference of its node. I don't think that's what we need here. J reference type, yeah, that's just going to be one of these here. Yeah, and there's no intersection types. Yeah, okay. So that's not going to work. We can't go that way. We can't ask it to build something like that, which means the constant pool of just, hey, grab the first interface you can find is probably correct-ish. I'm really loath to go with correct-ish, though. But it has worked so far. So let's maybe check to see who else has encountered a problem like this. Method references hit this problem, for example. And I was actually able to fix that bug myself. So let's find other references to this in GWT itself. Where else do we worry about intersection types? Let's see. Type binding. Oh, this is in JDT itself. I don't care about JDT. I care about GWT. This is the only place it's doing this. Interesting. 7. Yep, likewise, is the only place it's doing it. Okay, let me look in my notes here real quick, just off screen, for where we fixed this last time. Actually, in the same class, we're going to look for the end visit of a lambda expression. Let's pull up some notes here about who edited what last. So in order to make lambdas, we read what the type was and figure out how to make a new type that implements all those interfaces. And to do that, we say if it's instance of intersection type binding. Okay, so rather than saying if it is that and then cast it. So let's try that. Let's just Alt F7 for that interface. And I'm getting a phone call, which I need to check real quick. Be right back. Just a moment. Somebody wants my blood. Literally. Since the pandemic, it's been Okay, I have arranged to give them my blood. Yeah, since the pandemic, it's been they've been very, very grumpy about, hey, can we have some more of your blood, please? Okay, so here's another one of these we've got. Process type cast. This actually looks closer. This is going to take multiple... Oh, I see. It just calls back into here again. Into here, which is into here. Iterate through each one. Find the references. Build an array of references. Who uses this process type cast? This is... Which end visit is this? Doesn't say. It just says end visit. There we go. Message send. Message send. That's method invocation, I think. So it's going to say if it's... I don't understand what a value cast here would denote. Extra reference type cast to perform on a method returned value. That's the result, though. But that probably means if you use the result of another method to pass to another method, the inference we need to do. So we get an array of types. Process cast type. Could take a type binding. Because it sort of is a cast. We're sort of saying this this ternary, it has to be this union type. And we know that because we know what the two sides are going to be. I don't think we actually want to insert a cast, but we do want to get the right get the right upstream. Hey, this is the expression of the type. So what do we do once we have one of these? We say the type of this conditional is going to be this type. So that doesn't help us very much. That actually does not help us at all, because it's not going to accept an array unless we've got some other type that takes an array of types as an argument. So target types can be a maybe cast, which will iterate through and just chain the casts together. Okay. Not helpful. Maybe insert unsafe type coercion, J unsafe type coercion. Is that like a kind of a cast? No, it's not. It's just a, hey, trust this. Oh, it's unchecked cast. It's actually the implementation of unchecked cast. Hey, I needed this for JS enum. Cool. I'm going to come back to that then. We're going to need that later to get JS enum implemented. Okay, so if we have this cast here, maybe cast will result in... Oh, it's just going to push. It's going to push that new node. Because I don't want to create a cast. There's no expectation of there being a runtime cast check as the result of a ternary. The only expectation here is that we're able to dispatch to whatever it needs to be to say, hey, here's the type. Okay, so let's look at the other calls of process cast type. This is the one we checked already. This is a cast expression. Okay, that's easy enough. Build cast expression, which is just going to chain these things together. Cast types. By index, apparently. Oh, it only takes the first one. That's interesting. So this is actually, we'd be in pretty good company saying only take the first one. Seems suspicious to me that in multiple places we say if there's a union cast, I'm sorry, a intersection cast, we only take the first one. Process intersection types. This is exactly what we're doing here. We're saying, here's a new array to populate with all the things in here. Let's see if anybody calls this instead. That is the only call for process cast type. There's two calls for this one. That's promising. Interfaces to implement calls the same thing. And that returns explicitly interface types, because each one's going to construct its own array. Okay, fine. And then we're going to iterate through and make sure that the nested ones themselves are reference types. Yeah, that's it. That's all we got. Okay, let's look at intersection type binding, which is the not the 18 version. Oh, maybe there isn't a type for that anymore. Where is GDT util is intersection type, returns false, and it's overridden to true in wildcard binding. If other bounds does not equal null, then it is an intersection type. So that it is possible to get into a situation where a wildcard binding is actually an intersection type. Okay, so I guess we should look for who handles wildcard bindings elsewhere in the program. Let's confine this to project files. No references. Okay, so we pretty much never check this explicitly. We don't check it by saying, hey, wildcard bindings. One of the nice things about GWT being built as it is on top of Eclipse's JDT is that we pretty much can trust the JDT to have done all the parsing and type inferencing correctly for us. It already knows the answers. It's already checked to see what's going to make sense. And it's already gone through and said, okay, so for this whole expression, here is the type that Java nominally will think that this needs to be. This is going to be a wildcard, so we're just going to promote it to object or whatever the upper bound is for the purposes of resolving the rest of the program. Now, GWT will tighten types, and it will change types, and it will implement new types as necessary. But for the most part, it's just going to say, hey, someone's already done this work. I'm just going to trust that work is done. It doesn't need to validate this. In fact, it can even throw away some of these semantics as necessary, since after all, JavaScript just doesn't have a lot of this type information. There's no such thing as a cast in JavaScript. We have to actually spend extra work implementing the code so that you have casts, which will throw if you fail them. You can actually make GWT very slightly faster, something like 2 to 5% faster, and save very little bit of your Java runtime, your program runtime by turning off casts. Leave all the casts in your program, but pass a flag to the compiler that says, actually, don't write these casts out to JavaScript, because then we don't need to write all the supporting code. We still need instance of to say, hey, would you have passed a cast check? But there's no need to write out throw class cast exception. Now, obviously, this depends on your program never having a class cast exception in it, which, the majority of programs should follow that rule. You shouldn't generally be throwing class cast exceptions or catching them. And if you're not doing that, then it's safe just to say, well, I don't need the rest of this type check here. Okay, so the conclusion I'm coming to is that in multiple places, we already do the rude thing of saying, hey, it's an intersection type. Let's just go ahead and take whatever the first interface is, and we'll assume that's going to be the most important one. So we can loosen this here by saying, let's put this back where it was. Stop the debugger. And say if x.resolved type is intersection type or intersection type, then we're going to go ahead and assign this to be simple string. Let's split this so we can assign it in different ways. All right, and the way that this is going to be implemented is it's going to say, oh, I suppose we still need to get the right binding now. We'll just grab the first one. That'll be fine, because that's what this constant pool is going to do. It's going to grab the first non-object one in here. There's two different references to object in here, so probably we can just grab this. Erasure is not this. Then grab the eraser's constant pool name. You okay there, Streamlabs? Oh, I see, it's Dimitri. Good morning, Dimitri. Sorry, I missed you. Well, from my perspective, it was just Streamlabs saying the same thing over and over again. So we could just straight up call constant pool name, take the char array, value of it, but then we have a string instead of a type binding. And if we can't find some way to pass that into get. I don't think there's an overload for get that takes a string. We got field binding, method binding, and type binding. We don't have a way to take the string. So that key then will be used to look up source type. I can't. So it's gonna be interfaces because you can't union types. You can't union objects, multiple objects. So we'll take the first one. So just quick refresher on this error we're going to get, on this expression we're going to get. If you have a class, you put the class first. And all the rest have to be interfaces because Java doesn't have multiple inheritance. So if you have that ampersand symbol, you have to have a class, ampersand, am I going backward? You know, that's right, class, ampersand, and then interface, interface, interface. All the rest of the interfaces go their way now. So if you have a class, that is always the strictest and best thing to check. We'll start with that. If you have two classes, necessarily one must extend the other because we don't have multiple inheritance. So we will pick the more specific one and throw away the least specific one because there's no need to do that. We can just automatically promote you to the more specific one. And if you don't have any classes at all, we just assume object is the type. So we put object in there. Now we have to throw away object and decide which is the most important interface. And the implementation so far we're finding is just grab the first interface, which means hopefully you don't have something else that takes serializable specifically. I don't think you can write methods in Java that use intersection types. I think we can only use that for the type declaration. So it really shouldn't matter. Yeah, okay, I'm convinced. It really shouldn't matter. There's no case where you actually needed to have all of this to get the right type. Maybe we're going to have that problem with Java 9 var. Let's try that real quick for fun. What if we change this to put this in a var? Oh, we can't, because then I need Java 9 to work here, and the Java 9 stuff isn't turned on by default. Well, maybe it will be. Let's just try. I don't think it's going to work, though. See, my IDE notices it. We got the little highlighting here to say it's serializable and comparable. But notice that this is actually a different order than... Yeah, okay. Nope, it's because I changed something else. 650 here. Let's just do this for the moment. Yeah, there we go. Oops. So it's the backward order of what GWT detected it. I don't know if that's going to cause a problem. I don't think it will, like we already mentioned. It's just going to grab one of them. And GWT has already gone through and figured out what the binding needs to be if you're calling a method or something like that. So the type of var should already be handled. Let's see, class var. So yeah, it's because we're still in Java 8. We would need to specify Java 9 to get that. Okay, we'll deal with that later. Let's look for a test that uses var, some Java file, because I believe we have this support already in here. It's going to be in a test class. Oh, here we are, Java 10 tests. All right, so this is a GWT test case. And we're going to put a extra test in here for some ternary stuff. No ternaries in here yet. Okay, I'm just going to put a marker in here to say, hey, come back and fix this. We'll come back to that. Let's try. We can ask for what? Get each of the types we've got here. Constant pool name will give us the string. For arrays. Ideally, I was hoping for one of these type binding methods to be what we needed. I don't know what prototype is. Oh, good. We're looking for something specific in the intersection type to say, hey, try to find the whatever's going to be interesting about this so we can get the right answer. So one of these things is going to say, hey, here's how we handle this. Okay, so you grab the 0th one. If the 0th one is a class, then you return that directly. Otherwise, you return object. So that's the opposite of what we want. We want, if it is object, return the first one. Yeah, okay, fine. What other references do we have to object in here? This is creation. So it looks like when you do the class, it looks like it's already found this. Let's see what debug name does. Because maybe debug name is actually doing some more work than I was expecting. It's going through intersection types and actually logging their debug names and joining with % directly. Okay, so it already had object in there. Why doesn't this do as the Java doc says and return null when it's not a SAM type? It's an excellent question. Answer the first SAM we find. SAM is single abstract method, which is for like lambdas and method references. So we're looking for something that iterates through this and grabs and returns just the first option here. But it doesn't look like anything's going to do that for us. Which leads me to say that we probably need to actually have a way to call into GWT util.get or .signature and actually have it return. I guess we're not going to return this directly. Is JSO? What else does this in here? So could you have an intersection type with an array? No, you can never have that because arrays always implement certain interfaces. So you can't say, hey, this final class here, I need to intersect with these other types. So just to prove that to ourselves real quick, let's just write some code. If we have a string array, so if we had string and, I don't know, serializable, I don't think you can actually write it like this. We'll do so that's trivially true. It matches that cast. If we made this into a string array, we'll just make it a 0-length array. That's going to fail, but could we do this now? Yes, you can do that. So technically, you can have an intersection cast on an array, which means binding itself would not be an array binding, but you'd want to look at the first one to see what it returns. Ugh. I mean, we haven't seen this manifest itself in any case other than just concatenating to a string. So I presume there's something just interesting about concatenating to a string. Maybe we should see what's happening around string. Maybe string is the problem. Our string concatenation is doing something wonky. Did I forget to fix that? Yeah, I did. So if our string concatenation is actually the funny part, well, it's not ours. It's GWT string concatenation that would have the funniness around it. I think I really want a breakpoint for one of the earlier ones. We were trying to do some method dispatch based on the type of the expression and see why it doesn't end up with an intersection type here. So let's just find a way to get a good breakpoint in here. Something like x dot value if true instance of char literal. So we'll see if we can stop before that, and then we can try changing the expression to catch it a little bit sooner and see what it comes up with. Okay, we are not hitting the breakpoint. Did I do it backward? Value if true? Yeah, it's value if false. Guess no one's actually reading my code out there, huh? Alright. There's only 4 ideas. And I had 2 choices, true and false, so I was bound to get the wrong one just by flipping. Alright, so we're correctly stopping here now. We don't need to continue any further. We can change the test now to say, what happens if I pull this out into an expression? And we will make our helper methods here, public or private void go with a serializable I don't know, object and string. And then we'll just call go directly on this. So I don't think this is going to fail the assertion anymore, because the type of this is just going to be object. And I don't think that will either, because we tested it before, and I hope it still is consistent about that. A second here. Thought I had enough time there to type this message. I didn't. All right, so what are we doing here? We have a char literal on the one side, and the expression itself is true CC. We're going to ask for X resolved type is intersection type. False. It's not an intersection type. So what is the resolved type here? It's just plain serializable. So that means the JDT is figuring out that this is the most precise method to call for that. That's the most precise type that this expression could be here. Let's double check that here by saying, hey, what are you doing here with your message send? It's calling go on this, and it has picked the method, the implementation of go, which is serializable. It's decided already that that's the only correct implementation. So there's no error for this because it's already said, well, your type has to be this. But for some reason, in string concatenation in GDT, it will handle it differently. So we're going to do it again for the next case where we are in a local. The local is the serializable where we say true CC. And obviously, serializable is itself an object. And the binding here of this is going to be resolved type. Right here is just plain object. It just said that that's fine. We don't need to worry about the intersection at all. And that's the end of that. Okay, so let's go one step further and put it here. I guess I need parentheses. I don't know what you're complaining about, but we're not going to worry about it right now. Okay, let's try this again and see what it comes up with for the third one and why it decides that string concatenation needs that binding type. But it does at least suggest to us that it's safe for us to pick the first one, or even whatever we want. We don't even need to get too specific because it's just going to concatenate strings together. All right, so here's the first one where we're inside the message send, which is a method call. The second one, we're in the local declaration where we say serializable equals. And the third one where we're in a binary expression, which is how it decides to handle this plus. It says that we've got on this side AB, and on this side thing, and the what do you call it? The operator is plus. So I wonder if this happens for other operators as well. It's not going to happen for minus, multiply, divide, mod, equals. Probably won't happen for equals because, well, it might. We could try equals. That would be interesting. Putting a ternary with an equals, though, you just hate fun. Hate readability, anyway. All right, how do we embed the operator? Maybe it's in the bits? I hope not, that'd be irritating. It's a compound assignment, not a binary. Here we go, binary expression. And it does grab it from the bits. It says X bits, grab the operator mask, and then operator shift to get us just this int here. See, bits is it is an int. And then you can pick out which operator you're in. So GWT disambiguates between concat and add. And the plus operator in GDT is going to say, hey, check to see if your whole operation is a string. Then it's concatenate. Otherwise, we're going to assume everything else is add. Because GDT will have already decided that the entire thing is a string. So we should be able to pop up to right about here in our binary expression, traversal. It's already visited the node itself, so we instead will say alt F8 x dot, sorry, this dot, what do we call it? Not binding. Resolve type. It'll be this dot resolve type. So resolve type is string. So it definitely is confident we're concatenating together to make a string. So in that context, it doesn't actually matter what we're going to come up with. Anything in there is going to get built into a string, built up into a string. Okay. So now the question is, I mean, we're confident the solution will work. The question is now, is there any better way we can do this other than just removing this check here and saying it's okay if we get a slightly wrong signature here? Pretty sure we only check this in, yep, this one place here. And get itself must be referenced in several other places inside the reference mapper. Yep. Which means every path through this ends up hitting this signature check. So we have to either have decomposed the type already, or yeah, let's do that. So let's try changing this to something like get first non-object in intersection. Oh, it wants a field binding. We'll change it to a type binding. Yeah, we'll do an assertion just in case someone did something dumb. Okay, so now we need to iterate over, but it's going to be handled differently for each one. So how does the wildcard type handle the constant pool name? It just erases it and just says whatever you get, you get. We don't actually want the constant pool name, we actually want the first one. So in the case of wildcard binding, we'll just use erasure. Okay. I don't know how to trigger that, though. We're going to need to figure that one out. A equals B equals D plus D, where B left unchanged. They got that fixed, though, right? Or is that still a going concern? Okay, so how do I check if it's an object? Do we have like a Java-long object reference already in here? We do. All right, cool. So we can just go to Java, we can just compare does not equal Java-lang object. If type does not equal Java-lang object, nope, that's string. Return type. Otherwise, we continue. Oh, that's not quite right, is it? This is the J class type. Okay, so we need the Java-lang object reference for the JDT instead. So here we have from the compilation unit declaration, the CUD. We have in scope a Java-lang object reference. So this is really what we want to find. Is anybody else referencing this in here? Just the once. Yeah, okay. And I don't think, yeah, I don't have access to that. But this is a field, so we can do that. Okay. This is terrible. But we're going to go ahead and at least stub it in this way until we can figure out a better way to do it. If current cud.scope .java-lang object is what we're pointing at, or is not what we're pointing at, then we'll take the first one we get. Otherwise, that would be crazy, because that basically means an intersection cast with no intersection, or it's object and object intersecting each other, which is nonsense. Okay. Otherwise, we have case of intersection type, which is, we already said, it only covers wildcard bindings. So we're just going to return erasure for that. Okay. Going heavy on the asserts of things that we think are obviously true, just to make sure that we're not going to find some other fun problem later. I would really like to trigger this case here. I'm not sure if it's possible, but I would really like to try, because that could help in making sure that this is actually not nonsense. We could also just leave it broken, because it wasn't going to work before. We had already failed the is intersection type check, so we know that it's got one of those things are unset here. Reminder for this, it's an intersection type if other bounds is not equal to null. Other bounds is... I'm afraid I'm not quite steeped enough in exactly how you implement all the particulars of wildcard binding to speak intelligently about this here. We can look to see what assigns it. Nope, we can't easily do that. We can look in here. Boy, there's a lot of access. Can we just ask you real quick who assigns this? Yep, right here. So initialize gets passed into some other bounds. And then you've got some meaning out of that. Let's put that back on again, otherwise I'll get grumpy later when I can't find it. There we go. Okay, let's see if this fixes it. We'll turn off the debugger. Let's see, I've got a a ant XML file I need to turn that off for. That's in GWT user build XML. And then test it and see if that's good. I say good, what I mean is not broken. Well, it's taking a long time. I'm hoping that means success. Unless it's paused waiting for the debugger. No, it shouldn't be. It wouldn't have printed that line if it was. All right. So that passed the test. Let's think about how to trigger that wildcard binding. The problem is we need to trigger it from a ternary to cause this. What if we just leave this case deliberately broken for the time being? I think that's okay. So we will only try to handle it if it's an intersection type. We'll assert that. We'll log it in the case of failure, and then we will just go ahead and unconditionally run this. Check here. And now we'll change this to say, I'm unconcerned with your other wildcard intersection types because the GWT isn't going to synthesize those. Let's see, it unconditionally returns true here, so this could be an instance of. Yeah, let's go ahead and strengthen that to an instance of. Because that's what other code in this area is doing. So we'll drop this, promote that. And then we need to cast this. We've already done the type checks that cast is safe. We're not writing Java 17, so we can't just say, give it a new name here. We do this other places, so I'm decently comfortable with the pattern here. In fact, I'm the one who wrote this last time, but I had it reviewed by the original author of a lot of the stuff. So again, I'm pretty comfortable saying that this is an okay way forward. There's another instance of, but one that I didn't write. Roberto wrote this one. To say if the type is this, then we're just going to go ahead and process it as that. And here's back to ours again, the one we just wrote. Okay. We need to clean up the imports because I just added a garbage import to this. Reference mapper. I don't think I need this change. I don't think I want any changes in here. We definitely don't want that. We definitely need to come back to that. Compiler test. I don't think we need anything specific there. We can always put that back. I would really like to get this Java 10 test, just get a sample in here for how this might look. Let's see, it's not about lambda capture, it's about test local var type. I don't understand the convention. Why are we doing it this way? Is there something else that's going to reference this? Looks like there's 2 copies of the test. Assert false is source level 10. So we'll just do the same thing here, and whatever method we end up creating, we'll make a different one. We're going to say ternary. And then we're going to just do the expression itself. What are we going to do with that, though, once we get it? Let's do value.toString. Because it should box this up to a character, and toStringing a character should give us the string C. Really, though, we're not testing what the value is going to be. We're testing how the types here interact. Okay, let's turn back on the debugger and see if we happen to get into our check here. And now we want Java 10 test. Oh, I forgot to fix the other test. So I need to grab this method signature and go to Java 10 test.java, the non-supersource version. We did it just before the Lambda last time. Oh, that's not what I meant. There we go. There we go. Okay, let's see if that stops for us. I'm suspicious it's not going to, that the ternary is just going to say, it's an object, but there's a good chance it's going to grab the type inference correctly there. Or something new and equally surprising. There we go. Debugger is trying to run, and it's done already. And it failed the test. But it did not hit our breakpoint. Instead, it hit a null pointer. Running every single one, it hit a null pointer. So it didn't actually run the tests. Do we need to do something special to run Java 10 tests? Compiler suite should run this. Java 8 cannot be the first in a suite. It uses a hack to avoid executing if not in a Java 8 environment. So I guess we could run the entire compiler suite, but that's like 5 minutes. There might be something else funny happening here that we need all these to work properly. So let's just turn all those off to reduce the time it takes to get in here, because we don't need anything after that to run. So let's do compiler suite instead. Okay. See who's yelling at me. I am getting to inform somebody that in order to do authentication using HTTP, you have to use the authorization header because HTTP is dumb. I mean, it's not as bad as the refer typo, but whatever. Okay, so we're actually in here. Who are we compiling? Assert equals. Okay, so this is our original test. We are probably up here for compiler test itself. I don't see compiler test. Can I not read? Type declaration is compiler test, extends GWT test case. So apparently we're hitting the compiler test somewhere in here. Maybe there's more than one compiler suite. And I got the wrong one? No, doesn't look like it. Extra compiler suite runs the compiler test. Oh, we must have wildcarded that too. Okay, well that's unfortunate. But here we are. Okay, so here is the type binding for that. Still in the same type. Yep. Same. Interesting. It looks like this has been wrong. Oh no, this is two characters here. Okay, so we're just matching any character literals. I was not actually checking to see if it was a intersection type binding. Okay, so here's another one. It looks like it's probably the same test again. Compiler test. So maybe we're running it again or something. Wouldn't be the first time. So I'm wondering if I shouldn't just turn this one off at this point and say it's just always going to do this. And I'm not interested as long as I'm in compiler test. Or I could just start over from only running the one compiler suite. Test conditionals, yep, same thing. And then it ended. And nothing failed. So probably that means it fixed how it ran the test. Compiler suite. Let's look for the var that we were trying to hit here. There we go. Did not fail, also did not hit the breakpoint. I'm a little worried about that. Because it should have hit the breakpoint when it hit that character, unless I just skipped by it when I wasn't paying attention. Compiler suite. I don't see what other suite it would have run that would have triggered that. It says it just ran this compiler suite. I wonder if it compiled the other tests in the course of building this one, and that's why it ran into that. Java 10 test. So this should be a separate module name anyway. It should build it separately. Let's break the test. So it should fail. Sorry, not yet. Then we'll wait the requisite 200 seconds. Okay, we're just going to turn off all breakpoints just to try to cruise through this. Hopefully we fail here, which means we actually got into here, but it does mean that this was not the expected expression. It's possible that the GWT is saying, oh, you've got true here. I'm just going to go ahead and pass string A. So we need some kind of indirection to make it believe that this might happen. Well, that's not good. We definitely didn't run the test. I'm going to mute this because this is not helpful right now. So why don't these tests run? Test Java 10 features. It is super source, so it can be compiled under Java 7. Important for each test here, there must exist a corresponding method. Eventually, this test will graduate and not be super sourced. Yeah, well, unfortunately, Java 8 is still a thing, so we are stuck with it. So what if we try and break it worse? So it shouldn't even compile at all. I really need to turn this off. It's just going to irritate me more. There we go. Let's try that. There's nothing specifically in here about Java 10. I'm running with web mode, so that should trigger the script only to kick in. Yeah, this is really not behaving. So let's look at this file here and make sure it actually specified its super source. Java 10 test points to, should it be script only? No. It says there's a super path in here. Perhaps it's in the super test. Let's see, what's the package for this? It's com google gwt dev jjs. Super. And then com google gwt dev jjs. The original Java 10 test is this one, and it's in just plain old JJS test. Java 10 test. And this one is a JJS Java 10 test. So they should be, they appear to actually supersource each other. So why is the supersource not doing its supersource thing? Com google dev gwt dev jjs test. Do not run with dev mode. Okay, that's fair. Only run these tests if source level 10 or greater is enabled. So how do we make sure that that's set? JNet shell, compiler options, source level. Apparently it could be null. That's weird. So who is actually setting this high enough when we run these tests? Or rather, who isn't setting them high enough? Default source level is whatever your JVM is. So it looks like we need to bump this up when we run the test, which is done through, let's see here. Source level 11. Let's try passing this to the args here. That is unfortunate that these tests weren't being run. So we may need to spend a little time fixing how GWT does that. I'm going to take a break for lunch shortly here. This has been a short stream, and I apologize for that. But like I said at the beginning, fragmented day. Okay, now it's failing. Here's hoping... Oh, 91 errors. Okay, so I'm guessing this hasn't worked in a long time. Compiler... Suite. We need the suite. Here it is. Error constructing Java AST. Hey, look at that. It's our ternary. And then a bunch of other stuff blew up. Great. Probably blew up because of this failure. Okay, so why is this not getting checked? This should be a local declaration. Okay, so ternaries, var expressions need it too. We need to figure out what that type should be. My hunch is this is just plain wrong. Let's turn on the debugger this time and try to catch it for real. I'm thankful it's only 30 seconds to get the failure. We should catch the assertion directly when it's thrown. There we go. But we didn't pause on. Oh, I forgot to turn on the breakpoints again. Oops. I thought that I jumped the gun. Trying to catch it before it gets too far. And then probably turn off some of these breakpoints because they're not going to apply since we know we're actually failing. Okay, so this is one of the ones we're just going to go ahead and turn off. And that one, at least for now, we'll wait till we get our assertion, which is probably another 10 seconds. Oh, we did deliberately break the code, though. Well, let's wait until we get it failing before we go the next step of fixing it. Let's close all this stuff down here. Here's our assertion. Creating a local. So this is... This is the old code of creating a local. We were basically leaning on the JDT to say, hey, this is probably a... just treating like a regular type. Yeah, here we go. Var value equals true, then A, otherwise C. And it inferred the type as an intersection. So B is object and comparable and serializable. And the resolve type is object comparable serializable. So I think we also need to put this check here. If the constant pool name is not null, then we basically are going to say, okay, go ahead and ask the type map for the signature. Oh, it always erases it. Look at that. It always erases it. So this actually gets rid of your wildcard. Wildcard does not matter. This will only fail if you get a wildcard, and because we've already called erasure, we've already stripped off the wildcard. Okay, cool. So that's not our problem anymore. Now we just need the extra check of if resolve type instance of intersection type binding, then we need local type equals type map.get. Now this is not really right anymore, but it will give us at least an opportunity to figure out what else is wrong about this. I don't think this is right anymore. For strings, it was pretty easy. We could just pretty much assume that we were going to handle it that way. But for var, now the window is open to passing it almost anywhere and seeing what else breaks. Okay, let's shut this down and try it again and see if this at least nominally fixes it. I'm not going to turn on the debugger because we don't need to see that here. Okay, it failed. Did it fail for a good reason? Compiler suite is over here. Okay. Is this our failure? Did we break it? Line 2106. Well, that's not correct. Does not define a pen string that is applicable here. This is Java 8. What am I doing? Oh, I hope these are not broken. Maybe you gotta run each one at a time to make sure it actually matches. Let's look for our call, because it should actually fail. Yeah, right, because it's garbage. That's expected. It should be A. Okay, so that seems to behave. We get a value here, but the problem is we're not going to get the... If we make something like void go here and make a object and a serializable or comparable, it's going to depend on the order that it decided to pick. So either this is going to succeed like this, or I'm going to need to make another version with serializable instead. I just don't know the order of those off the top of my head. So at least we'll have this part fixed here. If this doesn't fail, we'll replace comparable with serializable and see if something happens. See if it breaks something. Okay, it failed, but at least our test passed. I'm hoping we fail, actually, but I'm hoping we fail for a different reason. Because then we got to think about how are we actually going to model these intersection types. I think it's probably the answer is we're in trouble. Or the answer is the compiler will figure it out for us. Sorry, GDT will figure it out for us and then just say, hey, something's happening here. I don't know what to do with this. But here's the method you're supposed to call. And GWT's going to say, yep, sure, great. I'm not going to think any more about that. Okay, failed again. We still got to figure out why Java 8 is falling apart. Java 10. Yes, it failed. It had compile errors. Oh, because of something else, I assume. No, it looks like something else killed the Java 10 test too. Serializable cannot be resolved to a type. Why did comparable work? Is comparable in Lang? Yeah, comparable is in Lang. Okay. It's funny because this is actually required for the compile to work at all. But here we are. Okay, so this is probably going to fail our style check because you're not allowed to be at all original with your import order. But we'll get that fixed next. Well, maybe we got to go back and fix these Java 8 tests, or maybe Java 8 tests to run properly, but only when invoked a certain way. The Java 10 test, I'm glad at least this is the only failure it appears we've got. All right, so what I'm going to do is I'm going to make two pairs of these, basically check if serializable and check if comparable. Okay, cool. So either way it worked because the GDT has already figured out and said, hey, that's actually going to be fine. Check, we're not going to say check if serializable, we're going to say check serializable dispatch and check comparable dispatch. Okay. Oops, there we go. Okay, so this one should be, it doesn't know because this isn't real Java code according to the compiler. but this one should be the actual comparable one and not object, and this one should be the serializable one and not object. So we're making sure that both of those are called correctly. Okay. Let's give it one more run, just in case I'm wrong here. I'm worried there's some other type tightening thing that's going to kill us, because it's going to say, oh no, this is only serializable and not comparable, or vice versa. But it doesn't seem to be doing that right now. So let's get this at least passing and checked in, and push it so that other users can give it a try. This is MP1 who found this, or at least resurfaced this bug. It's been hit a bunch over the years. We've got better logging, that way if you find something like this again, it should be easier to hunt down, and now we've got actual fixes for 2 of the ways that this bug can happen. So hopefully we'll get reviewed and merged and get snapshots out there with this working. It looks pretty safe to me, though. And then we'll figure out why Java 8 tests are not behaving. I'm betting there's something special in here about Java 8 tests. Actually, and then I'm going to go eat lunch. Here's the Java 8 suite. But this should run from the compiler suite. I don't know about that. Yep, passing. Cool. So we're going to change how we handle locals, because var can only be used locally. You can't make var fields, for example. Okay. Okay. Okay, other thoughts on this patch? Um, Something else I wanted to add on here to this comment here. Oh, right. What does GWT call them? Or not GWT? Wildcard binding. Right, the fix for this is 9694. Okay. Cool. I'm impressed. That only took us 2 hours. I'm going to go ahead and send this to the reporter, the most recent reporter. All right, I'm gonna get some lunch. I will probably not be streaming more this afternoon. I've got some stuff for the Eclipse plugin to take care of. Need to create up a new subdomain in gwtproject.org, and then deploy and figure out how exactly we're going to generally deploy new releases as those happen. So yeah, a little light on the streaming this week. Next week might be light too. I've got a morning call in the time I would usually start streaming. So we'll just sort of see how it goes. Thanks for hanging out. I'm glad we got this done. This feels like real success here to finish a fix like this. I will try to follow up later with what on earth is happening with Java 8 and those tests, because we should definitely be enabling those. And I'm very disturbed that they're just failing across the board. C does not define append string that is applicable here. Duplicate nested type C. Duplicate nested type C. Jeez. This is the wrong one. This is the hey, make sure it turns on one. We need to open the other one, which is also called Java 8 test and super source. And then look for C. Oh yeah, look at that. There's another class called C in here. How on earth is this? Who checked this in? Me? Oh no. Method references should correctly implement their intersection cat. Uh-oh. These have never been running. Oh no. That's awful. But I know that this ran because I got output out of it. It's possible that in the course of review this changed again. Oh no. Yeah, look at this. This shouldn't even be C here. It should be something else. I2, I1, append, C append. Oh yeah, here we go, C append. Okay. Yeah, I bet I just copied the whole thing. Wholesale. That's embarrassing. What a jerk. I2, I1. These are actual integers. Yeah. Oh man, I hope this tests actually pass. I mean, I know that this fixed it. Let's try that. See if that fixed it. Okay, I gotta run. I'm gonna get some lunch, but I'll be on Gitter, and if time permits, and if I get a good bite-sized piece to chew on for a stream, I'll come back again this afternoon, but I kind of doubt it. So we'll see how it goes. Anyway, have a good day. Justin will be back, I think, Friday, and like I said, hopefully we're gonna get Ahmed in the rotation here real soon. But he's busy with other stuff, which is good news. But it just slows things down here to get this going. So, all right, have a good day.